Thank you everyone for coming. So let's get started. I tell this tale, which is strict or true, just by way of convincing you how very little things since were made, that things have altered in the shipwright's trade. In Blackwall Basin yesterday, a china bark refitting lay, when an old shipwright with snow-white hair came up to watch us working there. Now there wasn't a knot which the riggers knew, but the old man knew it, and better too. Nor there wasn't a sheet or a lift or a brace, but the old man knew its lead and its place. So shipwrights are an artisan skilled in the tasks of requiring to build vessels. They were very highly sought after back in the days of wooden ships. A little less now that we have modern ship fabrication techniques, but still they were very, very highly skilled. However, there's a certain amount of irony. So that song I did was actually from Rudyard Kipling back in 1910, and it ends with, how very little since things were made, anything alters in anyone's trade. Now, I'm probably sure we're all in the IT industry here, and we all know there's a whole lot of altering in our trade going on right now. So today, I'm going to help you navigate through the rough waters of building with ships, the simple hierarchical in PowerShell provider. So firstly, we're going to ask the obvious question, what is ships? And it is obviously not boats. So actually, if you have any questions, feel free to actually interrupt me at any point in time, and I have a list of all my links and my resources at the end, and on my blog site, you can get all of the information today. So SHiPS is a PowerShell module, which makes it easier to develop PowerShell providers, which then begs the question, of course, then what is a PowerShell provider? So we've had PowerShell providers provide user access to things that would normally be a little difficult to get to via the command line, for example, like the Windows certificate store, and then presents them in a consistent known format, just like a file system. And providers have been around for a very long time, since PowerShell 1. And you're probably already using them, you just may not know. So you can use the get ps provider command, and you actually list all of the providers on your machine. And then you can use file system commands like get child item on the HKey local machine system registry key, and you can use other regular commands like get, set location, new item, remove item, etc. So providers have been around for a very long time, and we all use them. Why would I need ships then? So providers are great. They hide so much of the complexity and difficulty dealing with things like the Windows Certificate Store or SCCM. You just create a drive and start browsing. They're so great that many people start asking, I want to write my own provider. So surely there's plenty of help and documentation examples out there. Yeah, not so much. Writing providers is hard. So here's an example. The Microsoft documentation has a quick start, which is nice. But the first things you have to do is install Visual Studio, then install the PowerShell SDK, then create a class library, whatever that is, create a project reference, nope, no idea, and start PowerShell with a command line that uses reflection, whatever the hell that is. And this is an immediate barrier for most PowerShell users, because most of us don't even... Oh, I have yet to finish, my friend. Next, you have to have a solid understanding of C# and the tooling that goes with it. Again, most of us don't have that. And finally, you need to have a good understanding of the inner workings of PowerShell and the providers using the PowerShell SDK. Oh, and which versions of PowerShell are you going to target? Are you going to support Linux and Windows? And to give you an idea of the size of the problem here, I went through the PowerShell core code base looking at the standard providers. On the left-hand side is the provider. On the right-hand side is the number of lines of code for that provider. So for example, the registry provider has 4,373 lines of code. But look at that variables provider down there at the bottom. You're going 239 lines. Doesn't seem like all that much. Well, if you take into account all of the inherited classes in C#, you come out to over 3,000 lines of code for this, for a simple provider, okay? And this is where SHiPS comes in. What SHiPS does is hide all of that really complex C# code from you and simplifies developing providers. And it also lets you create the bits that you want in a language familiar to you, which is PowerShell. So now we understand why we would need SHiPS and what the problems it solves. But if providers have been around for a while, when did SHiPS actually become a thing? So the history of SHiPS starts back in 2014. And so this has been 5 years in the making. And to be fair, I've had to do a bit of reverse engineering in the archaeology here, so hopefully this is all right. So back in 2014, a community member called Jim Christopher, or Beefarino, created a module called Simplex, which is a PowerShell module used to create PowerShell providers using a DSL. Except I haven't clicked it, so you can't see what I'm doing. Not long after that, he released P2F, which is the PowerShell Provider Framework, which he describes as the PowerShell Provider Framework performs the heavy lifting of developing PowerShell providers, which basically all he did is he grabbed Simplex, ripped out the DSL bit, and just gave a framework that anybody could use in C#. And then sometime in 2017, the PowerShell team was working on the Azure Cloud Shell, which needed a provider. So they ended up creating SHiPS using P2F to create a framework so you could create providers in PowerShell script instead of C#. And in October, the Cloud Shell went public preview, and the SHiPS went open source not long after that in September. And since then, we've had a bunch of releases, the latest being 0.8.1. Why is that important? The history is important because it sets the scene for how SHiPS actually works and how you write modules for it. So what you see here is the architecture of SHiPS. You, the module author, writes PowerShell classes, which SHiPS then uses to interact with P2F, which interacts with PowerShell. All of that complexity below that dotted line is abstracted away from you by SHiPS. You don't have to worry about it. SHiPS makes it so easy, I can create a provider which you can mount, traverse like a file system in 16 lines of PowerShell code, not 3,000. This is working code right here. And I'm going to be going through writing a SHiPS module later on, but this is how small a SHiPS provider can actually be. So now you know more about SHiPS, but what can you do with SHiPS? What things can you SHiPS-ify? So there are quite a few examples out there. Deepak has a DHCP server drive. I have a Puppet drive, which can actually browse the Puppet master. If you were here early enough, you would have seen the text adventure game called Pirate Booty. That's a SHiPS provider. Ravi has a bunch, including both the browsing the PS gallery or the event log as a drive. He even has a SHiPS module to browse other SHiPS modules, which is kind of meta. Patrick has one to browse the AST of a PowerShell script. And of course, the PowerShell team actually has a bunch there for Azure Drive and SimDrive. But that doesn't really help you. What things can you SHiPS-ify? Now, I work for Puppet, and it provided me with the perfect answer, which is our company logo. This is a heart-shaped DAG, and anything that a DAG, you can SHiPS-ify. And if you're from Australia or happen to be a sheep farmer, it is not that kind of DAG, okay? Yeah, go research it, you'll find out. It's safe for work, it's okay. So the kind of DAG I'm talking about is a directed acyclical graph. So let's break this down. What is a graph? A graph in this context is made of vertices, nodes, or points, which are connected by edges, arcs, or lines. So the nodes are the yellow squares, and the edges, the edges are the things between them in white lines. Make sense? The answer is yes. Thank you. So what does directed mean? It means that the connections between the nodes has a direction. The connections between them have arrows, so you can actually see the path that they're having to take. Note that you can't have bidirectional arrows. So you can't have arrows at either end. That would be two separate edges going in two different directions. It also makes it easier to traverse the graph. So for example, we want to get from node A to node C, then the path is going to be A to B to C. And lastly, what does acyclical mean? It means there are no cycles, there are no circular references in the directed graph. So in this example, there are no cycles. But if I do this, we end up with this infinite loop going ABC, 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 ABC. Okay, that's a cyclical graph. You can do this though, because all that does is generate two paths to the same node, but there are no cycles. So it's a little bit of graph theory there for you. But what does it have to do with real life? What does a DAG actually look like in real life? And again, if you're in Australia, I am not a DAG. So this is the file system and the registry. They are DAGs. They are nodes connected by edges. AD org units or certificate stores, DAGs. Azure resource groups, also DAGs. Azure DevOps pipelines, or can also be represented as a DAG. Even the AWS CloudFormation design displays all of the templates as a directed acyclical graph. org units, networks, language, CMDBs, application menus. These are all represented as directed atypical graphs, and DAGs are everywhere once you go looking. But so what? Well, you can take a DAG and define it in PowerShell classes, which is then used by SHiPS as a provider. SHiPS just calls the nodes by different names. So this is a DAG representation of the SHiPS documentation. And what I've done is assigned each node and edge with the name you would need to use in SHiPS. So nodes with the children are called a SHiPS directory. Nodes without children are called a SHiPS leaf. And the links between nodes are the getChildItem function. And we'll cover this in more detail in the demo. As a side note, I'm not sure why the designers decided to mix the metaphors here. Surely it should have been parent-child or branch and leaf, just not directory and leaf, so I'm not quite sure why they use those words. So let's actually build a SHiPS module. So before I jump into this, you should possibly have some basic knowledge of how to write a PowerShell modules and be able to actually read PowerShell classes. Again, I'll have some links at the end if you want to read some more about this. And each step that I go through is actually in my GitHub repo as a separate commit, so you can actually go along as I'm actually doing this when you get the presentation details later. So a quick demo of what we're going to make. So what I've done is made a provider for the agenda for PowerShell Summit. So we're going to import the PowerShell Summit module. We then create a new drive called Summit 2019. We're then just going to quickly change our directory to Summit 19, just like a regular drive in a file system. And then we're going to get all of the child items. So for a summit, we're going to have speakers and agenda, fairly straightforward. Let's get all of the speakers. Blech. Let's get me because, self-centered. So there's my information. And what about the agenda? So this one's a bit more interesting. There are 80 sessions. We've got different tracks. We can get individual things. But we can also get individual sessions such as this one. So how to become a SHiPSwright. So we're going to build this module today. So first step, put your computers away. Get out a pen and paper. Actually plan what your DAG is going to look like. In this case, the summit has speakers and sessions happen on different days. So I drew up a quick diagram. There you go, you can love my chicken scroll. This is pretty much what you saw in the demo. For those that can't read properly, or I write really badly anyway. I quickly put an overlay on top of that so you can actually see the DAG up on the screen. So the speakers on the right listed under speakers directory. In the agenda, we can have a list of all sessions. And now we have an idea of what we're going to create, we can actually start to write some PowerShell. So first thing we're going to need is SHiPS actually installed. So you can either install it via the PowerShell gallery, or you can go to that link to actually how to install it yourself. And then we're going to create the root object for the drive. So this was just enough code so I could import the module and then create the PS drive. So if you remember from the DAG, this is the object that I'm going to be creating in this code, up in the top left there. So first you need your PowerShell module manifest. I've just cut it down to the bits that we need, which is the required modules of SHiPS. Obviously we need the SHiPS module in order to actually so we need to import the SHiPS module in order to actually consume it. That's it for your PowerShell manifest. Next, we actually create the module script. So much like the other example I showed you, the amount of code you need is actually quite small. So at the top, we have the using statement. So this is a feature of PowerShell classes, and without it, SHiPS is not going to work. Next, we define the root object for the drive. And you can pretty much call it any name that you like. I would prefer that you keep it small and simple, and I'll show you why in a few moments. Note that it inherits from the SHiPS directory object. So remember what I said back earlier. Objects that have children have to be a SHiPS directory. Next is the constructor for the class. It takes a single parameter called name, and then we pass that to the base class to process. This is mandatory for all SHiPS objects. Even if the constructor does nothing, like this one, you still need to define it. And in later steps, I'll use more complicated and lastly, the getChildItem. So this is what gets called when the user wants to get the children of the object. Self-explanatory, I hope. For now, we're just going to return an empty array. But this is enough that we can now import the module and actually get the drive and see what we've done. Some of you may have noticed this line up the top. I will go through this. SHiPS does have a caching mechanism. This is just a directive to turn it on. So let's import the module. And the next thing we do is create the PowerShell drive. Now, I've wrapped this over a couple of lines so you can read it a bit easier. So we create a drive called Summit 2019 with a provider called SHiPS. The root parameter is a little bit trickier. So it has the name of your module, and then a hash, and then the name of your root object. So in our case, the module is PS Summit NA 2019, and the name of the root object is Summit 19. You can call your root class whatever you want, but it's easy to keep it nice and simple because you have to type this many, many times. Make sense? Good. And then we get the child items, and there's nothing because that's exactly what we expect because we gave it an empty array. Congratulations, we have the basis of a provider. So next thing we're going to do is going to create our directories. So we're going to create the speakers and the agenda directories first. So first we had a basic directory called speakers. So remember the constructor must always call base with a name and then an empty child list and get child item. And then we have a similar directory called agenda. Same again, empty constructor and an empty child item. Now we have those two child directories, speakers and agenda. We need to modify the root to actually display them for us. So we add them to our array. So we instantiate them with their name, and then just add them to the object array. Same for the speakers, same for agenda. Let's try it and see what happens. So like before, we import the module, create a new PS drive, and then we use call get child item. We've got two things called speakers and agenda. Okay, that's nice. Not very useful yet. Step 2. Now we create all the speaker leaves. Let's actually display something useful. So what we're going to be doing is showing those leaves Alice and Bob in our DAG. So first we need to actually get the speaker information. Now fortunately, the web app for the Summit accidentally publishes the entire speaker list as a JSON file. So what I did is just download the entire thing, save it into a directory and that the module can find, and then I can just use that static data. So once I had that data file, I created some private helper functions, get speaker object, and remove HTML to help and read and parse the information. Get speaker object reads the JSON file, converts it to PowerShell objects. Remove HTML is used to strip HTML tags from the text, as unfortunately the web app kind of munges HTML tags and Markdown and all this stuff into the text field because it's a bit messy. Technically this API is private, so you can just kind of steal stuff. So now we can create the speaker object. So note this is a SHiPS leaf, not a SHiPS directory, because it doesn't have child objects. Next, we define the public properties of this object. So a speaker has a name, a first name and a last name, and a bio. Now, when we call get child item on all these properties, when we call get child item, these properties will appear in the list, not just the name, which is the default. But the constructor for speaker is a little bit different. We have the same name like the directories before, but now we have an extra parameter called data, or data. We can add additional parameters to the constructor. However, we must always pass something back to the base object, and in this case, it's called name. Make sense so far? Good. In the constructor, we call the populate from data method, which parses the data object and extracts all the bits of information we need to populate the public properties, first name, last name, etc. And then we use remove HTML to help, so remove HTML helper for the bio. Now, we could have all stuck this code from populate from data method directly into the constructor itself. And that's also fine. But I just wanted to show you can actually create private functions within the class. I mean, we could have also put this into a normal PowerShell function as well. And you may, when I talk about testing, you'll see why you can actually do this in different ways and why you want to do it. So now we have the speaker object. We can now modify the speaker's directory. So instead of an empty list for each item, so instead of an empty list, for each item in the JSON list, we create a new speaker object, pass in the name and the JSON data for that. And this is why I added in that additional data parameter. I already have all the speaker data, so there's no need to have to keep querying that JSON file over and over again for every single speaker. You can just pass the data in straight away. So let's see this code in action. Again, I was going to skip over the importing the module because you've all seen that. So now when we get the child items, we have all the speakers. And if we expand on all the properties of the speaker, you can see all of the public properties that we created, name, first name, bio, and so on. So hopefully you begin to see a bit of a pattern here. We create a small thing, we test that it works, we expand on that small thing, test that it works, and just keep rinsing and repeating. So let's expand this a bit further. It's time to add our agenda information. So we're going to be creating all of those objects in the graph now. So again, how did I get the agenda information? Well, just like the speakers, I managed to rip down all of the agenda information in a single JSON file. Saved it. Got a couple of helper functions, just like before. We've got a get sessions object, just like get speakers, except it's for sessions. Get sessions also allows me to return sessions with a filter, which I will show a bit later, because you only want certain sessions. And my favorite, convert from epoch time. Yeah, for some reason they decided to use Unix epoch times for the time zones, and I'm in Australia, and trying to convert that to Pacific Standard Daylight Savings Time was real fun. Yeah, date times are hard. So again, we create an object called agenda session as a SHiPS-leaf object. Then we create the public properties for a session ID, name, etc. And note there's now a hidden data property at the bottom. So this is how you can mark properties private so the SHiPS provider won't show them to the users. And then we have the constructor for the agenda session. Just like the speaker object, we pass in the data for the object too. But notice the use of ID at the top, not name, which we used to use previously. We couldn't use the session name for a couple of reasons. Firstly, for a SHiPS object, the ID has to be unique within that directory. And unfortunately, when you list all of them, breakfast does appear a few times. Same with lunch and dinner. So we can't use a session title. Also, it might contain some illegal names, legal characters such as / or /. You can't have them in the names of your objects. But a session ID is a number, it's unique, it's safe to use. So now we have an agenda session. Time to create an agenda track summary object. This is where it gets a bit more complicated. So the track summary objects, all of those all or day one things in the DAG. Now the interesting things with SHiPS, you don't have to use a single object per node. You can have the same class doing multiple things. So we use this trick for the agenda track summary. So we create an object called agenda track summary. And notice that directories can have properties too, not just leaf objects. It has the name, the number of sessions in the agenda track, and a private filter property. And this property is what we're going to know which sessions the track summary will show. For example, the track called all, the filter will be empty. If a track called day one, the filter is going to be day equals 1. Track 2, day equals 2, and so on. And this is how we can use the same SHiPS object for multiple nodes in the DAG. Then we have the constructor. Like normal, it has a name. It also has the filter that this track summary will use. And you can see how we can use the get session helper function down the bottom there. It makes it easy to read what's going on instead of having massive bits of code in there. And finally, because this is a SHiPS directory, we need the get child item method, where we get all of the sessions based on the filter and then create agenda sessions for each item. Yes?
You're using array list. Can you highlight why you chose that?
Where are we? Yes, because it has the add method on there. So I can actually add things on there as opposed to recreating the array every single time. For this example, doesn't matter. If you've got a whole lot of items, matters a lot.
Yeah. So people don't know, if you just did that as originally it was an array, when you add elements to array, the array gets copied each time, and so it can be exponentially horrible. So this is the best practice.
Thank you. I'm glad I got that right. Hopefully the rest is like that. Okay, so now we can modify the agenda directory to create all the summaries. So let's go. So here's the old agenda get child item, nothing. And here's the new one. So the first part, which is highlighted, is somewhat straightforward. The agenda has 5 track summaries. The top one is called all, has an empty filter. All the sessions, day 1, Monday, has a filter of day equals 29 because it's the 29th of April. And day 2, etc. Fairly straightforward to follow. Yes, is the right answer?
Verbal confirmation.
Thank you. This part is a little more complicated. So I found in the data there are actual talk tracks For example, this ship talk is in the PowerShell language track. So the first loop there goes through each session and finds all of the unique track names. And the second loop then takes those unique track names and then for each item creates an agenda track summary for each track. Sound good? Okay. So let's see this thing. Oh, yeah, sure.
Is there any connection between the track summaries and the agenda, or is it the agenda item? Are there any reference between them?
There is an ID tag between the two. Thank you. Okay, so let's get the track summary name and the number of sessions in each track as a table. And ta-da! There are 80 sessions in total, with my favorite being meal, having 9 sessions. And so the agenda track summary object is working. What about the actual session information? So let's see what the first 5 sessions on Tuesday are. Yeah, not really useful. Let's try that again. So we're going to add the property asterisk at the end to get everything. Much better. Breakfast is the first session on Tuesday. Unfortunately, there's too much to show on one slide, but you get the idea, and believe me, it's down there somewhere at the end of this text. So that's a lot to take in. Right now, our module is fully functional. You can find speakers and sessions with some nice filtering, but we can make it even better. We can modify our leaf objects to give content, so that when users use the getContent commandlet, it actually gives them something useful. And we do that by adding the getContent method onto our leaf classes, which just returns a string. So for the speaker object, we're just going to return a markdown file with the speaker's name and their bio. And then for the agenda session leaf object, which returns some markdown text with the session name, time, and location, and a long description of the session. So again, let's see what this looks like. So we can use the getContent command on speakers. So this is me. And what about the session today on Tuesday? Note we have to actually use a session ID, not its name, because that is how we're referencing them inside of SHiPS. And there's the session information. Now, of course, if you're using PS6, you'll be able to use the show markdown commandlet, which makes this look really pretty, but that's in PowerShell 5 for you.
One of the tricks I've done, I've had that problem with the ID. And so what you can do is you can be anything you want. So you have the ID, and then you can concatenate the descriptive name.
You can concatenate the descriptive name?
Well, yeah, that's the thing you do. You just take the ID and then the name, you concatenate it with colons, and then you get uniqueness.
Okay, thank you. You should do this talk.
Be sure and repeat that for the recording.
Yes, so for the purposes of the recording, you can use the ID, which is fine, but you can also concatenate the description of it with a colon to separate between the two. Thank you. I always forget that. So let's add some leaf connections. So we can make the module even more useful. In the sessions, it doesn't actually say who's actually speaking, which is a bit of an oversight. Also in the web app version, you can't see the sessions. Well, previously you couldn't actually see the sessions for a speaker. That was actually added after I actually started doing this talk. So what we're going to do here is create additional links between the leafs, which is actually a little bit dangerous because remember, you don't want to create cycles in your DAG. So in the DAG for our module, if the speakers had links to their sessions and sessions had links to their speakers, we'd end up with this, which is a loop. So we can't do that. What we can do, though, is we can give hints, but not direct links. So the session object can give the names of the speakers and the speaker objects, and the speaker object can give the session IDs. That way, the user can actually use the set location command and traverse around, but not actually create any loops in our DAG. So for the speaker object, we're going to add some information, and we'll add some public properties, like how many sessions the speaker has, the name and time of the sessions, and most importantly, the session IDs at the top there. And then the populate method, we can use the getSessions filter to find all of the sessions the speaker is speaking at, and then populate those public properties. So now the user has more information about the speaker with the session IDs if they need it, and we haven't created any loops in our DAG. So next we can modify the agenda session object with the speaker information. Again, we add the new public property called speakers. And then we populate this by going through all of the speaker IDs for the session and then finding those IDs in the speaker JSON file. So again, now the user has more information about a session with the speaker names, and we haven't created any loops in our DAG. So if we have a look at my speaker information, we can now see all of the session information, which is just highlighted in yellow for you. And if we have a look at the session, we can actually see the speaker names. Much nicer. So the module is working fine, but it doesn't actually look very nice. The default properties that are showing aren't very useful, so let's make this thing look pretty. So PowerShell uses XML formatting files to tell PowerShell how to display objects. So I'm not going to go into detail about this, as there's plenty of other blogs and documentation that does it much better than I can. But you can start with the PowerShell help system, which is about _format.ps1xml. And there are probably people in this very room or conference that can help you right now to actually write these. So we can create the formatting XML file, and then we can make the module use that in the module manifest by specifying the formats to process setting. So let's see some before and after comparisons. So let's get the first 3 speakers as a table. This is what it used to look like, and now a lot nicer. It shows the most common information you actually need right away. You don't have to use select object to get the properties you want. What about the sessions? Yeah, great. But now, much better. And that is how to create a SHiPS module for the PowerShell Summit agenda. So I went through a lot of things, so I'm quickly going to recap. Start with some planning. Draw a picture of what the module will show the user. This is the DAG, and the DAG may change while you're developing the module, and that's okay. But I find it really useful to have some idea of what I'm going to actually write when I do the module before I actually start writing the module. Create the root object first, then create the directories, then create the leaves. Do not try to do them all at once. A process that I found really useful was just make a small change, try that, make a small change, try that. It really helps you not being overwhelmed with trying to do an entire SHiPS module at once. And lastly, don't worry about making it pretty at the beginning. Get it working first, then make it pretty. But what about some more advanced information about SHiPS? So in my example, we use static data files, which is all well and fine, but what about using remote services like an API? Well, it's PowerShell, so you can do whatever the hell you want in SHiPS. If you want, you can query with invoke web request or invoke REST method. So this is another quick example of a provider that I wrote. This is a GitHub provider. So on the left is the Puppet PowerShell module in GitHub. On the right is that provider querying the GitHub API. In theory, you could have multiple drives hooked up, so you can have different branches, so you can compare the content of 2 different branches in PowerShell without ever downloading or doing a git clone. But that does bring us to the next topic, credentials. So how do we manage credentials for a provider? Well, you need credentials for the GitHub module I just showed you. The Azure SHiPS module does too. And currently, the SHiPS module does not allow you to pass credentials from the new PS Drive commandlet. If you do, you end up with this sad face. So what can you use then? You have a couple of options. Firstly, can you please add your comments and your +1s to GitHub issue 110, the SHiPS repo, so the maintainers know you want this? You can store tokens in environment variables, like I did for my GitHub provider. But you can also store the authorization information in a file or in the registry, pretty much anything outside of the realm of PowerShell, in particular global or module scope variables, which seems like a very odd thing to say, but this is due to an architecture decision in SHiPS. The variable scoping, or more specifically, the run spaces used in SHiPS will trip you up, and it took me ages to debug this. When SHiPS creates a drive, it also creates its own run space for each drive to operate in. So this means exported functions or global functions will appear in both the default run space, which is where you import your module, but there will also be an independent copy when the PS drive gets created. So I'll run you through an example of why this trips you up. So we're in PowerShell. So let's import our GitHub PS module. So we import our module. It sets up a global variable called GitHub token, so we can store our API token to talk to GitHub. We then set our GitHub token to ABC123. So excellent. Let's create a new PS drive and use our new token. We create a new PS drive, but behind the scenes, it creates a run space and imports our GitHub module into that. So note we have 2 variables now. You're squinting at me. called called global GitHub token and 2 functions called set GitHub token. And importantly, the drive run space doesn't have a GitHub token in it. So anything we do with the drive, like get child item, get content, happens in the drive run space, not the default run space, so you don't have the token available to you. Even if you call set GitHub token again, it's going to modify it in the default run space, not the drive run space, because when you call the method, you're over there. Does that make sense? Yeah, it took me a long time to figure this out, and it tripped me up really hard. This is why you need to have things outside of the run space realm to store your credentials, environment variables, files, and registry. So earlier I mentioned that SHiPS had a bit of a caching mechanism. I can't say that word, I think money. So the SHiPS cache is turned off by default. But when you turn it on, SHiPS will cache the object directory as it gets created or used, which makes it great when users are traversing up and down the directory tree. Of course, if you want to, you can use your own caching mechanisms as well. But you can turn it on a SHiPS provider attribute on a class just by using that small class attribute there. SHiPS has other features as well, some of which you may have used on other providers. Earlier I showed you how to use the get content, to use the get speaker and agenda content. SHiPS also has set content. Obviously, you can set things inside a provider. So for example, I could set my own bio if I wanted to in my agenda. You're probably already used to using the pipeline to filter, but sometimes it's preferable to do the filtering at the provider level. So SHiPS supports filtering on the SHiPS directory object. So here I'm getting all the speakers and using the filter of Glenn. The top one will be using the pipeline, and the bottom one is an example using SHiPS filtering. Dynamic parameters are additional parameters passed from get child item. For example, I could define a dynamic parameter called track, which takes a value of general. So return all of the sessions that are in the general track. Or perhaps all of the talks on day 2, or the speaker called Glenn. I could combine them all together. So there's a lot of content there. The best place to actually get more information about the dynamic parameters is actually from the samples dynamic parameters inside the repo for SHiPS. They've got some really good examples in there and good documentation. And testing. Yes, you can test your SHiPS provider. They are PowerShell classes, so if you struggle with testing PowerShell classes, you can just put your code into a normal PowerShell function and test that instead, if you're more comfortable with that. But you should test your provider. Yes? Thank you. So you've used SHiPS, and you like it, but it does have some significant limitations right now. It doesn't support passing credentials, as I said. It's only got a small list of supported commandlets, so you can't use new item or remove item. It also doesn't pass through the drive information inside the provider context, so you have no idea where in the path a SHiPS object actually is when you're trying to develop it. But you can make changes to SHiPS because it is open source. However, the SHiPS project is unfortunately quite young as an open source project. Why does this matter? It's still a little bit difficult to contribute and to figure out how the project works. It's missing GitHub tags for releases. The changelog is incomplete. It uses a different Git workflow than what a lot of the other PowerShell projects use. Excuse me. And unfortunately, there are no unit tests actually on SHiPS or P2F. There's only integration tests, which makes it a little bit difficult. However, the narrative documentation is fantastic for SHiPS. So there's still some hope. In fact, I have high hopes that Microsoft is going to make more time to invest into this project to make it easier for the excuse me, community to contribute. So wrapping up, SHiPS is a user experience module. It wants to make the life of the user easier. So always remember, what will the user experience? If you feel overwhelmed when you start, make small changes and test it and loop and iterate. Read the documentation. It is very useful and has full examples on how to use the advanced features. And always remember the DAG because graphs are everywhere. Thank you very much. Excuse me. Sorry. The question was, what about putting a loops inside of your DAG? What's going to happen to your provider? What you're going to be doing is basically hitting the limits of file path. So you can go CD A, B, C, 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 and then fall off the edge of the stage. So you can put loops in there, but it actually makes it really hard for the user Because you can imagine if you're writing a SHiPS provider and you're saying, I'm going to respond to object C. All right, that's great. What about ABC? What about ABC, ABC? What about ABC? And you can get the point. So loops are bad. It's not strictly true of the object because you've got an interface on top of it, so you can't add methods. Yeah, you've got an interface on it. You can't add methods to the directory object because SHiPS hides it for you. Because your object, sorry for the recording. So the two things was you can output the string to the path, which is fine, and adding a method to your SHiPS directory object. The SHiPS directory object will go to P2F. P2F will then call the underlying objects to PowerShell, and it doesn't transfer the method through to that, so you can't see it.
Oh, I did.
Yeah, which is...
I did it to the types of the property.
You can do that, but they don't get surfaced. They don't get surfaced through to the provider. The user can't see them. I tried that trick for the credentials. Didn't work. But we can talk about it later, that's fine. I am holding you from lunch, so feel free to disappear if you want, but I'm happy to answer more questions. Was this enjoyable?